Welcome everybody. Today we're going to start talking about our electricity in our daily lives. We're going to start looking at how electricity is used in our houses. All right, so let's get started. Okay, so the first thing we're going to talk about is electric power, all right, and what that even is. So in our houses, we're constantly turning on electronics. We're plugging in our phone, we're turning on light bulbs, turning on TVs, whatever that may be. Anything that's plugged into a socket is plugging into our household electrical circuit, all right? Now, we've spent a lot of time on simple circuits, so we have an idea of wiring objects in series and parallel. All right, we're going to cover that another lesson. I'm getting a little bit tired of doing VER for the moment. So we're going to look at something a little bit different, and that is electrical power. All right. Now we can start that discussion with light bulbs. All right, and that's what we'll kind of think of when we're talking about plugging stuff in. So I have, the older. There's all kind of light bulbs now, but the standard used to be, simple things like this. And if you can see up here, it says 60 watts. All right. Now, what does that have to do with anything? If you remember way back the first time we dealt with power, all right, we found out that the SI unit for power was the watts. And maybe the first thing we thought of was light bulbs. And that didn't make any sense at the time. How can we relate light bulbs to what we were doing, with talking about potential energy and rocks falling? It didn't make any sense. So now we're at a spot where we can finally put that all together. All right. So let's start getting into the definition of electric power and how that relates to electricity and then our house as well. Okay, so we're going to look at a simple circuit here. All right. This will represent our household circuit. This 120 volts represents our sockets. That's the access, or you can think of that as the thing that's supplying the voltage. All right. And if we plug something into that, right, let's just imagine plugging one thing into it, and there's a resistor. So let's think of this resistor, that it doesn't have to literally be a resistor. It could be something that we plug in, all right? That's what the resistors have represented in our circuits discussion so far. So let's imagine this is a fan. So if I plug a fan in, it starts to spin. Well, we know that something is spinning has kinetic energy. So the question is, where did that energy come from? All right. Well, obviously, by plugging that thing in, it got energy. It received energy in the form of electric energy. You can call it electric potential energy. We kind of kept that kind of basic, but obviously, it's turning our electric energy into kinetic energy. All right. So that's the idea. But where that electric energy is coming from is where we'll eventually get there. All right. But what we have to start thinking about is, well, if I get that energy, who's giving me that energy? All right. Not literally where it's coming from, but what company is providing that energy? All right. So let's start thinking of where we're getting that energy from instead. And focus more on like the companies, not literally the science of the energy. All right, and you'll see what I mean here in a second. I'm going to show you an analogy. All right, so let's talk about energy in general. All right, and here's an analogy we'll start with. All right, if we need to go running, we've talked about this before with the law of conservation of energy. What happens is we take our chemical potential energy and we turn that into kinetic energy. And how the body does that, that's biology, all right, and anatomy, and chemistry, they can deal with all that stuff. But for our point of view, all right, we eat a hamburger, right, goes in our stomach, and then our body can convert that hamburger energy, which is chemical potential energy, but I like to call it hamburger energy. Hamburger energy we can turn into kinetic energy. We can turn it into our motion, all right? And the question is, where do we get our hamburgers, and how do we get that? Well, it's basically like this. We go to McDonald's, right? And McDonald's gives us a hamburger, and then we turn that hamburger into running here. Now, here's the key, and here's what we're going to kind of start talking about is we have to pay McDonald's for this hamburger, all right? So we're essentially giving McDonald's money so that we can move, all right? And that's the short part of it. The long part is we get McDonald's does whatever they need to do, and they sell us energy in the form of a hamburger. Now, this is my drawing of a hamburger. Notice it's a cheeseburger because there's a cheese melted down, and obviously the hamburger is really well done. So that's what they sell us in terms of energy, all right? And then we take that and turn it into kinetic energy. Another analogy would be is we go to the gas station and we buy a gallon of gasoline for our car, and then our car turns that into kinetic energy. All right, so we are buying energy. We are buying energy. So now if we take this analogy, we'll stay with this analogy, all right? If we take that analogy over into our house and our fan, all right, well, there's our fan giving us using kinetic energy because it's moving and it can, push the air around. Well, where is that getting it? It's getting from its electric energy, which we'll call the current, all right? Because if it's not getting current, it's not getting electricity essentially, and it's not going to be able to move. The question is though, where are we getting our current from? It's not McDonald's, all right? It's not Wawa, all right? It's not magic. We are not plugging into these outlets and it's magic from there. There's no such thing as magic. I hate to break it to you, all right? Now you may think, well, what we've done this before. We have batteries, all right? And yes, that is true. We could have a battery. That would be our voltage, which would supply our current, and then this thing can turn that into kinetic energy. But there's a big problem with the batteries, all right? They die. Yes, you have rechargeable batteries, but then you're right back into plugging into the outlet, and then our original question remains. And the other thing is, if we talk about a battery, we still have to buy those, all right? They cost money. Just like hamburgers cost money, the batteries will cost money, all right? Now, where that is coming from, or how they're, we know how they're kind of making a battery with chemicals, and those chemicals can get depleted, and that's why batteries die, all right? We know we can buy batteries from the local stores. But what about when we're not using battery, when we just go in there? Where are we getting that from? And the answer is our electric companies. Sometimes they're called power companies, all right? And in South Jersey, for the most part, I believe it's in this area, it's PSE&G. Down where I'm from, Millville, I believe it's Atlantic City Electric. All right, if you go over to Philly, it's PECO. All right, if you watch the Flowers, it's a PECO power play. They're all energy companies that give us electrical energy. And they deliver to our house through, all the cables and the wires and the telephone poles, sometimes underneath the ground, whatever. All right, how they get it there that's not the conversation now. All right, but once we know the company we're getting it from, all right, we know our company in this analogy is selling us hamburgers for energy. What does PSE&G sell us for energy? There's no hamburgers in there. That doesn't make sense. You're not plugging into a hamburger, all right? So what exactly are they giving us, all right? And that's what we're going to explore next. All right, so PSE&G does not sell us batteries. There's no big batteries in your house where you're getting all your electric from. All right, now there are starting to become exceptions where you have solar power, you could have batteries in your house, and that's great, but that's not what the majority of the houses have. That's not historically what how houses have begun electricity. So what PSE&G sells us is a kilowatt hour, all right? Now, it's a kilowatt hour. You may think, well, kilowatt, that sounds like power. No. Watt is the SI unit for power, all right? So watt is the SI unit for power, but for energy, it's a kilowatt hour. Now that seems pretty weird, all right? And I'm gonna show you how we come up with that and why we use that. And also, we're gonna get a little equations and start figuring these things out so you'll see how this comes about. Now notice this is a kilowatt hour. It's not a kilowatt per hour. Per means below. All right, so it's not kilowatt per hour, it's a kilowatt hour. And how you need to start thinking of this kilowatt hour is essentially that's your house's hamburger energy, all right? This is what we're buying from PSE&G. That's the energy we're buying from PSE&G, whereas the energy we buy from McDonald's is just a hamburger, all right? So we buy kilowatt hours, all right? So let's kind of further explore that a little bit more and see where all this is going. Okay, now we know what we're buying from PSE&G. We want to start to figure out how much things are going to cost us, all right, to run, a light bulb, to plug in these things and run them in our houses. All right, so let's start figuring out what that means and how we can calculate this. And we'll start with our analogy of running in hamburgers, and we'll kind of try to continue that because that's an easy analogy that everybody understands because they have experience with it. All right. So we look here, if I run about 6 miles, all right, that is going to require about 700 calories, all right, about. So that's how much energy it takes for me to go 6 miles. Now that's about one hamburger from McDonald's, and that costs about $1, all right? So I know all those things. That's pretty easy to figure out. So what we want to be able to do is, well, what if I run that fan who's using the kinetic energy? How much energy is that, all right, from PSE&G? Remember, we're not buying the hamburgers anymore. We're buying kilowatt hours. So what we're going to have to figure out is how many kilowatt hours does it take to run a fan or something for 15 minutes? And then once we have that, how much does that actually cost, all right, to run that fan? All right, so let's start figuring this out, and we're going to have to start using some equations here. Okay, to start to figure out how much it costs to, run our electronics in our house, we have to get an idea of how we're buying our energy from PSE&G. All right, we all know how to buy our energy from McDonald's. We walk up to the counter, we go to the drive-thru, and we order how many hamburgers we want. All right, how many cheeseburgers, and they tell us a price, and we hand them the money, and they hand us a bag full of cheeseburgers. Well, you can't do that at PSE&G. You can't walk up to a PSE&G store and say, I'd like 5 kilowatt hours, please, and they'll put it in your bag, and then you take it home, and you can load it into your house. It doesn't work like that, all right? So how does it actually work? Well, let's look at our McDonald's and see how maybe a different way of looking at buying our hamburgers. So let's imagine we have a rate at which we're going to eat these hamburgers, all right? Let's imagine I go into McDonald's, I sit down, and I eat 5 hamburgers an hour, all right? 5 hamburgers an hour. If I stay in there for 1 hour, then that means I'll just have 5 hamburgers, all right? If I continue eating 5 hamburgers per hour, all right, and I stay in there for 2 hours, all right, then I'm gonna hamburgers. It is the hamburgers, all right? So the point is, if we take our rate and multiply it by the time that we're doing that rate at, all right, in this case, we're doing 2 hours of 5 hamburgers per hour. That gives us our total number of hamburgers eaten in that 2-hour period, all right? And then I would know how much I owed afterwards. So I'm not buying my stuff up front. I'm seeing at the rate at which I eat these and how long it takes me over what period of time, and then I can buy them, all right? Okay, so it's pretty easy to figure out our rate of eating hamburgers at McDonald's, but how does that translate into physics and our electricity, all right? Well, if we think back on the equation for power, power was work divided by time, and essentially work is the rate at which you're using energy. If I do 10 joules of work on something, I've changed its energy by 10 joules. All right. Imagine if I lift this eraser into the air, all right, I've done work on it, and I've taken my hamburger energy and put it into gravitational potential energy. All right. So it's a rate at which I'm doing work. All right. In other words, our energy use. I use 5 joules of energy, hamburger energy, into here. Now, how fast I do that is how powerful. All right. We've all we've studied that before. So let's kind of use this equation. Look over here. So we see power is our rate. When we divide something by time, that becomes a rate. All right. So our power is the rate at which we use energy. All right. If I can use up power faster, or sorry, if I can use up energy quicker. If I can convert 100 joules of hamburger energy into kinetic energy quicker than somebody else can, I'm more powerful. I'll be faster, I'm more powerful. All right. So power is the rate. So power, we can see is joules per second, which is also a watt. All right. So a joules per second is like having hamburger per hour. See how it's like the same time. We have energy over time, hamburger energy over time. Now for us, a joule per second is equal to a watt. So power is in watts. We have joule per second is the same thing as that. All right. So now let's start putting it all together with our hamburger rates and our electricity rates. Okay, so let's put these two things together. Remember, to get our total, we just take our rate and multiply by time. With our hamburgers, it's our hamburgers per hour times 2 hours. We get our total number of hamburgers. Fairly easy, all right? Well, what if we have something that has a power rating, like a light bulb, a power rating of 5 joules per second, all right? And if we do that for 2 hours, what does that give us? Well, it's kind of weird. I'm not sure what these things mean. But remember, a joule per second is the same thing as a watt, all right? And so if we take a 5-watt light bulb and run it for 2 hours, that'll give us 10 watt hours. And now remember, that's energy. That's energy, all right? 5 times 2 is 10. A watt times an hour is a watt hour. So now we've used 10 watt hours in that 2 hour time span, all right? It's the equivalent of eating 5 hamburgers in 2 hours and you get 10 hamburgers total. Now we just have, instead of hamburger energies, right, we have electrical energies, all right, 10 watt hours. So what we want to put that together, how we got this down here, how we see we got this, we can see that that's power, watt is powers, and that's time, and that gave us our total energy. So we can just kind of reconfigure that one simple equation, and to get our energy, we just take our power rating, all right, and multiply it by the time that we use that particular thing, all right? So let's look at a problem here and see how it we can do one total problem, all right? Use equations and work all the way through it. So I would just want to know how much it costs to run a light bulb for 1 month. Let's imagine you turn it on and you never turn it off. And maybe it's a security light bulb outside. You know there's houses, maybe it's your house, maybe there's houses in the neighborhood where you always know that one light bulb's on, all right? So how much does it actually cost to run that thing for 1 month, all right? Well, let's see. All right, there's going to be 2 steps, all right? And I'm going to work you through this. But there's 2 major steps. The first thing you do, calculate the total amount of energy that you need, all right? Using that equation, energy equals power times time. Now remember, you have to convert to kilowatt hours, all right? And I'll show you to do that. Remember, the last example we had was just watt hours, but we need kilowatt hours. And then once we do that, we then just have to buy our energy, all right? So let's run this problem, and we'll use our light bulbs that we started with. These are 60 watt. Basically what I want to know is if I plugged one of these things in, just left it on for a month, how much would it cost me? All right, remember these are 60 watt, it's a 60 watt light bulb. All right, so let's look at how the math shapes out. Okay, so to figure out how much it costs to run that light bulb for an hour, we see we have our stuff here. We have a 60 watt light bulb. Now remember, we don't buy watt hours, by kilowatt hours. So we just got to convert that into kilowatts. All right, so there's 1,000 watts in 1 kilowatt, just like there's 1,000 meters in a kilometer, just like there's 1,000 grams in a kilogram, just like there's 1,000 liters in a kiloliter. It's all the same. That's why the metric system is beautiful. All right, and we have our light bulb is 0.06 kilowatts. All right, that's the rate at which it uses energy. Now our time is 1 month, and we just convert that into hours. 30 days in an hour times 24 hours in a day, because remember, we're going to leave this thing on for the entire time, and we get that thing is going to be on for 720 hours, all right? So to get our total energy, we take our power and multiply it by our time, all right? And when we do that, we get this number here, All right, 0.06 times 720, and we have, what is that, 43.2 kilowatt hours. So that's the amount of energy that we have to buy from PSE&G just to run that light bulb for 1 month straight. All right. Now, what do we do with that? Our second step is to buy our energy. It's just like going to McDonald's. If we know we have to buy 10 hamburgers, all right, and it's $1 per hamburger, well, it's going to cost us $10. All right. So the question is, how much does a kilowatt hour cost? And that's where you probably have no idea. All right. Most high school kids have never paid an electric bill. All right. I didn't until I was in college, and I don't even know if I was in charge of that. It might have been one of my roommates. I don't remember. But once you get a house and are paying electric bills, you start to get an idea of how much it costs. And if you, now that you have all this, you can actually really look into what you're actually buying instead of just sending a check to somebody. All right. So kilowatt hour costs about 20 cents, and it fluctuates just like any other energy prices fluctuate. Gasoline prices fluctuate. Gasoline is just energy. So our electrical energy for the house is going to fluctuate as well. All right. Right now, I'd say it's about $0.2, so about 20 cents. So we have 43.2 kilowatts, and it's 20 cents per kilowatt hour. All right. We just take our total energy and multiply by how much it costs, and that gives us our bill for the month just for that one bulb. All right. And $8.64, yeah, that's reasonable. A household can afford to pay about $9 to have a light bulb on. All right. Now, if you get your conversions wrong and you're getting that it's $864 per month, $860 per month to run a light bulb, well, that doesn't make any sense. Nobody could afford to have just one light bulb on in their house. All right. So $8.64, yeah, that's reasonable. You could go around in your house, and if you knew the power rating for all the stuff you have plugged in, you could come up with a good idea for your electric bill. All right, for that month, you can calculate how long it's on, multiply by its power. Make sure you do the conversions for watt to kilowatt, and then multiply by about 20 cents, and that'll tell you how much it's going to cost. Now, granted, they charge you some fees and tax and everything, so it, that's not literally exactly what your bill is going to be. But to put in perspective, my latest bill for this first full month of quarantine was about $80. All right, now I live in a small little apartment. I keep it fairly cold. Now I have electric heat, which is not good. All right, so that makes my electric bill go up. And I've been watching a lot of TV because I've been home. All right, so normally it's a little bit less than that. Now in the summer when I'm not around, I have I don't run the air conditioner that much, so my electric bills in the summer are a lot less. All right, most houses, if they're living there, they run their air conditioner, and that takes up a decent amount of electricity and energy, and that can run the bill up pretty good. All right. Now, one question that still remains is, how does PSE&G know how much electricity you're using, how much energy your appliances and all your electronics are using in your house? Well, they have meters on your house, and they're outside, and I'll show you what that looks like here. All right, here's my electric box. This is my electric meter box. Now, I don't live in a house. I have a small little apartment, and for this building, there's obviously 4 meters here. All right, and each one of those keeps track separately of individual units' electricity usage that they have. All right, and I'll show you what this looks like up close. All right, here's our electric meter. You can see it's measuring in kilowatts, and you have all those dials pointing to these different numbers. All right, if you look at this disc right here, all right, right there, you can see that it is moving, it is rotating. All right, as that's showing us that the thing is using electricity. The faster that rotates, that means you're using more electricity. These numbers will go up quicker, all right? Now what happens is they come out and get a reading here, all right, and then they get a reading 1 month from now, and the difference in those two numbers, or where those dials are, is how many kilowatts I've used, all right? Now, it is possible for that dial there to go backwards and rotate the other way. With that, and so then the kilowatt hours would go down. That means you're actually putting electricity and energy into, or sending it back to PSE&G, and they'll pay you for that. So if you have solar or wind, you can actually generate your own electricity. So that is our lesson on electric power. All right, how we figure out the cost of running electricity in our house. All right. Now, one thing we have still not done is we said we plug it into our sockets, and that gives us the energy. Well, where does that energy actually come from? We know we know PSE&G is selling it, but how are they making the energy? All right, it's different than McDonald's. McDonald's is getting the raw meat and cooking the hamburgers for us. We're all pretty familiar with that process. But how in the world is PSE&G making electrical energy for us? All right, that would be the next question in this discussion. Unfortunately, we have other science we have to learn before we can answer that question. And if that's keeping you up at night, don't worry. We are going to get to all that, and you can get the full picture of how you're able to charge your phone up, all right, and do TikTok videos, and how I'm able to do this video, all right? So thanks for watching, and I'll see you when I see you.